and Ultraleap. In this session, we'll be discussing the recent shifts and changing attitudes toward touchscreen technology and introducing some impactful touchless interface alternatives. In addition, there will be a demonstration of a touchless embedded GUI application development using Crank's storyboard development platform. Today's panelists include Alex Doplinger, Director of Product Marketing for the Building and Energy segment at NXP Semiconductors, Tom Trill, Vice President of the Americas and Asia Pacific Business Development at Ultraleap, Jason Clark, Co-founder and Vice President of Sales and Marketing for Crank Software. During the webinar, you can type in your questions in the question box found in the GoToWebinar control panel. We will address as many questions as possible during the live Q&A at the end of the webinar. With that said, I'll hand it off to Jason Clark.
Thanks. As mentioned, I'm Jason Clark. I'm the VP of Sales and Marketing and one of the co-founders here at Crank Software. If you aren't familiar with Crank Software, we are an embedded UI solutions provider. So as the tagline says, we're accelerating tomorrow's embedded UI experiences. We're doing this across all different segments with our software and our services, helping customers take the design concepts that their marketing and design teams come up with and helping them implement them in an embedded space on resource-constrained devices or leveraging the different capabilities of all the different processors and platforms that they can run on. We're doing this across multiple fields from medical, industrial, wearables, automotive, and smart home. The problem that we're solving is very generic across the board. Everybody's looking at how to make a better user interface and how to do that. The way we do that is through the help of our flagship product, our storyboard development environment, which provides a great user interface development tool for building up rich user interfaces by bringing in designer tools and making it easier for the design team and engineering team to go back and forth by sharing being able to import Photoshop files, sketch files, build up animation timelines, and not only that, but re-import them to make it easier and faster to get these products to market. So this is key because we are the display technology in this world, but people have to interface with these different user interfaces, and touchscreens have always been the standard way, or hard buttons that people have been interfacing with user interfaces, but that's evolving in today's world. So the challenge, the need to rethink the touchscreen interactions. Why are people looking at doing this? Well, there's a lot of different reasons. First, people are always looking for a better and easier, more natural way of communicating with a device. That makes it easier for the end users, a more natural communication method. And sometimes people are looking at voice, gestures, and other technologies, things that are a little more how we would communicate with each other in our day-to-day lives. The other thing that's happening is hardware is accelerating and constantly evolving, and it's becoming more feasible than ever before to take some of these concepts that have only been seen in like movies and virtual concepts, and now with today's increased computing power and ability to offload some of these technologies to other things like using the GPUs and such, is making it a lot easier to add sensors and sort of process this new ways of communicating. And as we're all very aware, the health concerns of 2020, are also affecting how people are thinking about how they communicate with devices. What is it like to use communal surfaces either at work or in public spaces? And maybe we need to rethink that sort of mindset of what we're touching and how we're touching. And where we're doing that. So I'll start off by just sort of taking a look at what we're seeing in the marketplace. Now, some of these we have customers today implementing them. Some of them are evolving and coming along, so we expect to see them soon in the embedded space, and some of them are a little bit out there, but they're all different ways of dealing with this. So as the goal of not touching things, goes, people are looking at different ways. So gesture recognition is one of the big ones, and we're going to do a little bit of a deeper dive in that today. That would be more like cameras or haptics, sort of being able to see where your hands are, what they're doing, and be able to detect movements such as swipes or position or different combinations of things. So it's a very interesting one. It does make a very nice way, especially dealing with large screens and such. Touchless sensing. This is usually just a piece of what's happening. This has been happening every time you walk through an automated door. Somebody's sort of sensing you coming towards it, but they can also sense distance and stuff, and you can use that interactively. We've used that in some of the user interfaces we've done before. Not so much as a sole way of interfacing with the device, but more as just an auxiliary. So as somebody came close to the touchscreen, that it would sense that and then start moving the touchscreen as it knew where they were going. Voice recognition, we're all very aware of this. Every time we talk to Alexa or Google Home or something in our houses, our telephones, voice recognition is becoming a bigger piece of technology that a lot of embedded device manufacturers are integrating into their device, either directly or indirectly. Facial recognition is another one that's we're seeing. Identifying people's faces and doing stuff. It works in small interactions. If you just need to unlock a door or something like that, but it's not really a full solution as far as a touchless interaction method. Eye tracking is also another one that we're seeing come along as far as a way that people are interacting. The biggest way we see that right now is more safety inside of vehicles, where they're tracking people's eyes to see if they're distracted driving, falling asleep, and such. But there is a lot of technologies where they're able to track the gaze and such. So they can see where users are looking and start moving the UI through that method. And then the last one, it's not quite a touchless device, but it is a personal device. So you're not touching the touch screen that everybody else is touching. You're touching your own touch screen. And this is also part of enhanced user experience. You have a appliance at home. Maybe it comes with an application for your phone. You can control it with your voice, and it's all these different multimodal ways of inputs coming together to create a device. But we're seeing this more and more today, where a lot of customers we see, they not only build a device, but they build an application to go with it, and then they can also communicate through there. So the user can either interact directly with the embedded device, or they can communicate indirectly through the sort of phone application. And we're also seeing it too nowadays with sort of touchless sign-ins, where you go into a building or a restaurant and there's a QR code that you scan, and then you do the sign-in on your phone, so you're not touching communal devices and such. So there's a lot of technologies coming. They're evolving. There's different spots that they're coming along with. It's all very interesting. As we in the embedded space start to think about that, we really have to start thinking about, what ones are for me, which ones should I be thinking about? And, a lot of this gets into what's the environment that your product's going to be running in. If it's a consumer device in the house, maybe it's not such a big concern, but maybe you would still add some of these technologies on more for usability. And, most consumer devices are already adding on voice, either directly or indirectly. And when I say that, I mean, you can tell your Alexa or your Google Home to turn it on, turn it off, however it might be. So, it may not be doing the voice processing directly on device. It might be in the cloud through one of these services, but they're adding that sort of interaction. Workspaces are, if you're in those spaces, some of these might be interesting, especially punching in security codes, going through different doors. If there's standard screens you're working on, you may not want everybody touching them. So it does get into an interesting communication there. And then public spaces is probably the biggest one we're thinking about now with regards to the health concerns. And that one's very interesting too, because, there's touchscreens in kiosks, movie theaters, shopping centers, when you get your groceries. And, is there a way that we could communicate with these without having to touch them? Different markets, this varies different. So automotive is a very market that's sort of grabbing a lot of these technologies. You do see gestures inside of there. As I mentioned, the eye tracking's inside of there. Voice has always been, you've been able to sort of communicate to your car for a while now with a voice, either integrated through your phone or not. So it's a very marketplace that's grabbing onto a lot of these technologies, but we're starting to see it trickle out to some of the other ones. So as I mentioned, the consumer space, when you get into the house products, but medical industrial are always coming right behind with, depending on the different types of devices, whether it fits or doesn't fit. But they're everybody's always looking for that next evolution of what to add to their product and what makes it easier for customers to interact with their devices. And yes, I couldn't resist putting a picture of Tom Cruise from Minority Report. Every time somebody talks about futuristic interfaces, Minority Report comes up. So, what are some of the concerns that people have with this? Just putting on new technology just because you can. That's never the recommended way of doing things, because the number one thing for product failure and success is user experience. If users like using your product, it's great, and if they don't, that's problematic for your survival in the marketplace. So you need to make sure whatever you do is intuitive. And it gets into a lot of questions you have to start thinking about when you're adding technologies like this. Is there extra training need to be done? And you just have to think about, like, even just how we interact with our like at home devices for voice, like Alexa and Google, that you start to learn how to say commands correctly. And you whether you think it or not, you are being trained by them. Um, you get into different questions of accuracy and how to deal with the accuracy, because voice, you always see a lot of issues. Gestures can have sometimes problematic issues like that, so you have to make sure that you've trained the device and you can deal with the accuracy issues. But don't think accuracy is only on these new technologies. I'm sure all of us have dealt with a touchscreen that wasn't as accurate as we'd like it to be, whether sitting on a plane trying to pick a movie and can't get the mouse to, or be able to select the button we want. As you add more of these technologies and have more ways to interface with your device, there's more testing that has to go on. There's more possibilities. Your permutations and combinations of different ways that the user can perform a task start increasing, and that actually puts a bigger load on your testing. And so you do have to think about these things. Design considerations sort of captures all of those things. You have to start thinking about the design of your product and how people are touching it. And you can't just always take a design that you have today and just say, I'm just going to add one of these other technologies. You have to think about how those interactions come through. How does voice interact with it? How does that show, and how does it reflect? How does gestures come in? How do other technologies come together? And then at the core of this, we're all building embedded devices that, there is cost sensitivity to many of the devices we're building. We do need processing power. You may need more sensors, whether it be cameras or microphones or whatever it might be, to drive these things, including processing power. So you really need to start thinking about, if I'm going to start adding these two new technologies, what is the overall cost of that? So with all that said, I'm going to pass this over now to Tom from Ultraleap. And so Tom's company, Ultraleap, is right in the thick of this conversation with what they do at their offices, and I'm sure he'll be able to give a great perspective on all of this.
That's great, Jason. Thank you very much for that introduction. Hello, everybody. My name is Tom Trill, and I'm from Ultraleap. I'm very happy and grateful to be here today, collaborating with Jason and his team at Crank, and Alex and Megan and their team at NXP. This is certainly a very topical issue that we're addressing today. User interface is and has been at the very heart and the very core of Ultraleap's mission and vision. With that said, let's meet your digital hands. It may seem like an oxymoron, but enabling what we call natural interaction without physical contact is precisely what Ultraleap Technologies strive to enable. Avoiding physical touch is really quite poignant nowadays, and despite what may be the normalization of a COVID-19 world, and that's with or without vaccines, we believe this may be, in fact, an inflection point in the adoption of touchless user interfaces. Favorite slides, because it really articulates the essence of what we're trying to achieve here at Ultraleap. We think about our ancestors, and their creativity was just simply not constrained by 2D tools or by peripherals such as keyboards or the mouse. These earlier generations created and built 3D objects in a 3D world using their hands. Our technology at Ultraleap effectively enables a return to this natural interface, this natural human interface, albeit in a a non-analog environment. I mentioned on the previous slide that we may in fact be on a cusp of an inflection point in terms of the migration to natural user interfaces. Now, that's a very bold statement to make, but there are many reasons and some validation in the market to underpin this claim or this notion. They range from the very obvious technological gains, and we'll talk more about that in the upcoming slides, to health and safety. Health and safety not only in the context of COVID-19 and the emergence of touch-free environments, but also in more general and broader terms around ergonomics. And that's not to mention the positive environmental impact to be gained from the elimination of all those plastic accessories. This is my other favorite slide because it just simply does a good job of conveying the wow factor. Now, I know the wow factor is a little bit of a cliche, but there genuinely is a wow factor associated with our technology. And in these 3 video clips, you can see how the technology just doesn't fail to put a smile on the user's face. I'll leave it there for a moment so you can see how these users are interacting using their hands naturally without any accessories, and they're engaged and they're having a little bit of fun along the way. When we think about the interface of the future, there are a number of core components, ranges from 3D displays to voice rec and so on. A multidisciplinary integration of technologies is clearly necessary to deliver this interface of the future. And from this slide in particular, the marriage of HMI, 3D spatial interfaces, and the underlying processing capabilities all working in unison is very much critical to the entire successful evolution to what we at Ultraleap call the spatial interface technology stack. Clearly, the collaboration today on this webinar between Crank, NXP, and ourselves at Ultraleap feels like a very natural fit in this context. Ultraleap offers 2 core components of this stack, the hand tracking and midair haptics. We've built and we continue to scale our company on a foundation of IP that spans over a decade of R&D. And we continue to evolve our solutions in a way that not only addresses, but also takes advantage of the continuous improvement and advances that are being made in sensor technology, high performance and low compute nodes, edge compute nodes, software development environments from the likes of Unity and Unreal, and in general, artificial intelligence. So let's jump in and take a closer look at the first of our 2 core technologies. In this slide, we talk about hand tracking. You'll see an image sensor, which is just below the laptop. And by the way, the I/O is USB 2, a relatively inexpensive and generally available I/O. It captures the user's hands, which are then represented on screen in the form of those skeletal renders, the blue and the green one, through our interaction engine. In the bottom right corner of the slide, you'll see a useful visualization of the interaction zone, this 3D volumetric space in which the user can interact with our technology. Later in the presentation, I'll run through a couple of short videos to show a variety of these interactions, or the most commonly used interactions. But before I get there, I'd like to highlight 2 very fundamental requirements of successful hand tracking technology. We've mastered both. We continue to improve and set the industry standard. They are latency and accuracy. To deliver the best user experience, you have to have a level of latency which is imperceptible to the human eye. It's a prerequisite for successful hand tracking. In the slide, you'll also notice how we identify and track a number of unique points on each finger, hand, and joints. With this granularity, we essentially enable a class of fidelity and accuracy that leads the industry. Midair haptics is the second of our core technologies at Ultraleap. We essentially turn ultrasound into touch. In the middle of this slide, you'll see an image of one of our more popular products. It's called the Inspire. It's essentially an array of ultrasound speakers, and they transmit ultrasound waves. The speakers are triggered one by one in a sequence with very specific predetermined time differences that allows the individual ultrasound waves to arrive in the exact same point in space as one another. In the bottom right corner of the slide, you'll see a nice visualization of just how that happens with an array of transducers. Each sound wave has a predetermined or predefined time interval, and they all arrive at that single point in space. We can determine that point in space in real time. The combined force of the ultrasound waves actually generate enough force to create a pressure point on the surface of your skin. Those pressure points can be moved around very quickly, which creates animated effects. Or, you can use them to sculpt lines or shapes and give a tactile sensation on the palm of your hand. In this slide, we'll scroll through a number of different sensations just to give you a sense for how we can manipulate and program ultrasound waves to form patterns. So the first one is a click, and there you'll see a dial, and it'll continue through with lightning. Again, it's a good visualization of how we deliver ultrasonic sound waves in predetermined patterns on specific points in space, in this case on your hand. At this point of the presentation, I thought it might be useful to run through a few example interactions. This is a short video clip. I'm just going to hit play. Some of these interactions you'll be very familiar with. Some will be a little novel. Maybe you'll not have seen them before. Clearly pinch, one of the most common gestures in a hand tracking. This represents our hand tracking really quite well. You can see the dexterity and the fidelity of our ability to track. In this automotive center stack example, we're integrating haptics along with hand tracking to replicate sliders and buttons. And one of the more common ones here, point and click keyboards and so forth, and a few nice novel futuristic AR class UIs with menus and virtual keyboards. Again, we're back into automotive here to give you a visualization of some of the AR components. This is an automotive center stack demo that just wrapped up there, integrating both haptics and hand tracking. And again, back here to VR. You see this user using his hands very naturally, no accessories. So as we say, we think these 5 interactions are core building blocks. As you've seen in the presentation up to this point, there's a lot of fun. There's a lot of novelty through the gamification of platforms using our technology. We could easily and very quickly get wrapped up in some of the hype, but we don't. We spend a lot of time grounding ourselves in reality. We work closely with our customers to ensure that we're delivering demonstrable, quantitative as well as the qualitative value propositions that they can deliver onto their customers. In this slide, we have 3 scores based on 3 tests that we did in 3 very different segments. AR, VR, XR with the automotive assembly line, assembly prototypes. They reported a positive gain of 30% in cost savings. Within an advertising immersive brand experience, there was an improvement in user engagement, dwell time, and brand loyalty. They scored it at a plus 60%. And with the kiosk and appliance operator, they reported that 55% of their consumers are more likely to choose gesture control over a touch screen. So there are some very clear metrics associated with our technology, and we're constantly tracking this. It's a very important activity for us. I'll take a quick moment here to show you some real world examples from the fields per se. In the top left corner, we're training robotic arms for industrial applications. Just below that, it's a direct manipulation of physical objects with robotic hands. And one of my favorites is the top right, the drone example, where you're conducting the flight by using our hand tracking technology rather than a joystick or a keyboard. And then on the bottom right, a telepresence application that combines AR, VR hand tracking and rovers. So you can see how the robotic image sensor is tracking the person's head. So in a very unpredictable fashion, when the pandemic struck, there was almost a natural manifestation of and convergence of all of our technologies come together, and all of a sudden there was a massive spike in demand for touchless interfaces. This is really the topic du jour, when hand hygiene has really become more crucial than ever. And it just boils down to people are reluctant to touch public screens. So as a result of that, we have drawn from our lineage in hand tracking and our haptics, and we've developed a variety of touch-free interfaces. In order to frame our development of a touch-free interface, we conducted a variety of surveys, pilots, and user testing. These results here are from one of the early surveys that we took this year. No surprise to anybody that's been living through this pandemic that the majority of respondents believe touchscreens are unhygienic, that our interfaces are more hygienic, and in the future, 73% of respondents are likely to interact using touchless gesture control in the future. In fact, we have just recently formally announced and released our touch-free app. This app quickly converts a conventional touchscreen into a mid-air interactive user experience. One of the core differentiators between our solution and some of the others that you'll find in the market today, such as IR Field, is the fact that we have a 3D volumetric interaction zone. This benefits both the content creator and the user in terms of flexibility, level of engagement, and the UI itself. Our software application runs on standard kiosks, advertising totems, and so on, and essentially just detects the user's hands and it'll convert it to an on-screen cursor that can then be used to drive the menu system or the advertisement or whatever campaign is running on the display. And it's really simple. It's almost like a plug and play. It sits on top of existing apps and requires no changes to the existing user interfaces. Of course, we recognize that Ultraleap alone cannot drive the mass migration from a touch to a touch-free user interface. There are many constituents in this ecosystem, and we all have to work in harmony in order to create and deliver the spatial interface of the future. We are particularly energized and happy to have the opportunity to work with both Crank on the HMI side and with NXP on the underlying semiconductor side of this, the creation of this platform. And we're grateful to you for joining the webinar today and looking forward to the Q&A session. With that, I say thank you on behalf of Ultraleap and looking forward to the Q&A. Thank you very much.
Thanks, Tom, and Jason too. I'm Alex Dopplinger, Director of Product Marketing for the Building and Energy part of NXP's Industrial Edge Processing business. NXP is a global semiconductor company that's built our expertise in business over 60 years. Together with the partners like Crank Software and Ultraleap, We support more than 26,000 customers across the automotive, industrial, and the Internet of Things markets. With more than 10,000 R&D engineers, NXP ranks among the world's top 100 patent applicants. We've heard Jason and Tom describe interesting developments for human-machine interfaces. Humans connect with the world using all our 5 senses, so wouldn't it be wonderful if the machines could interact in the same way? Why don't they already do it? What underlying technology is needed to make these solutions feasible? Many HMI tasks are easy to run in the cloud, where the processing performance is spread across huge server farms, and powerful algorithms can be shared by many users. However, many embedded human interfaces need to stand alone. They must work even when the cloud is offline or the network is down. They must respond even if everyone in the building is logged in and overloading the bandwidth. Many interactions need privacy and security, and sometimes it's best to never let our information leave the building, or if it does go out, to keep that raw data off the cloud and to transmit a smaller set of semantic data. Finally, it's expensive to transmit every little gesture or facial expression to a cloud service. Processing at the edge helps us to avoid expensive network costs, such as cell phone data fees. So what kind of a hardware platform is needed to process touchless interfaces at the edge? For each touchless interface, we need a processor that integrates the right type of inputs with enough processing power and security in the appropriate form factor with enough low power consumption and manageable heat profile. These embedded systems typically operate without fans in all kinds of environments: hot and cold, wet and dry, dirty or clean, noisy or quiet, for industrial, outdoor, or climate-controlled environments. Above all, they must be affordable to install, to operate, and to upgrade over a life that can span more than 20 years. And that's our sweet spot. For each of the 5 senses, NXP has a broad range of processors, technologies, and partners to help innovate your next product. We're continually thinking about how to solve the new challenges and to be ready when you are. NXP's scalable processing continuum offers a broad lineup of ARM-based industrial applications processors and microcontrollers. Industrial, consumer, and automotive devices may be built with our MCUs based on ARM Cortex-M cores and can scale up to the popular i.MX applications processors built on various combinations of Cortex-A cores. These are available with industrial-grade reliability, security, and product longevity needed for truly embedded systems. NXP's range of scalable edge processing devices integrate powerful combinations of features for a wide range of embedded applications. Many MCUs embed hardware accelerators for power conversion, metrology and charging, motor control, voice and audio, display and touch, some vision, and machine learning. As you scale up into the i.MX apps processors and the Layerscape processors, we add even higher performance for many of those same features, plus graphics processing, increased vision and video, and machine learning capabilities. These all offer options for wired and wireless connectivity, either built into the chip or with an add-on processor and software and tools from NXP and our partners. So now we get into a bit of the how to do it. We heard that Ultraleap technology can support intricate gestures from fairly close by. We also support customers who want to recognize gestures that are almost touching, such as pointing at the screen, or a comfortable meter or so away. And some of them are much further away using technology such as sonar and wireless ranging. These are sometimes combined with voice for more flexible and robust multimodal interfaces. So now let's see how one device supports almost all these approaches. Here we see the ins and the outs of an apps processor launching soon. The iDATAM X8M Plus can bring in many different camera streams to interpret gestures, facial expressions, and movements. Stereo vision cameras can use either the MIPI CSI, the USB, or Ethernet connections, together with audio inputs to recognize speech, and sound generators to provide audible user feedback. A display panel can also give visual instructions and feedback to the user and may incorporate backup touchscreens in case the contactless control fails or will not be used. Depending on the complexity of the input, the interface software can run on either the ARM Cortex-A53 or M7 cores, or the GPU, or the DSP. And if that's not enough, this is the first iDATAM X processor to add a neural processing unit, which is a specialized hardware for machine learning and inferencing. After the gesture, environment, and camera types are understood, we must acquire or build gesture recognition machine learning model. The left side of this figure shows the steps needed to convert gesture examples into an inference engine, which is the algorithm that actually recognizes the gesture. Gesture recognition systems are typically built with single smart camera connected to a general purpose computing core, or multiple camera sensors feeding multi-core processors with highly optimized vision and machine learning accelerators. The figure shows two such options for a gesture recognition system, recommending an iDATAM XRT microcontroller platform on the bottom for simpler systems, or the NXP iDATAM X8M Plus applications processor on the top for more complex or faster responding gesture and vision systems. It's clear that more touchless controls are needed to keep users safer and to improve our interaction with machines in harsh industrial and manufacturing environments. We're excited to be at the forefront of these new developments, and we hope to hear from you soon. So now I'll hand it back to Jason, and he can show you how Crank software can help you build these interfaces a bit easier. Jason?
Thanks, Alex, for that. So now that we've heard a little bit about the marketplace, Ultraleap has discussed their solutions. NXP's talked about what they're providing into the marketplace to help customers with these next level of UIs. I thought I'd just do a quick demo showing one of these touchless interfaces. And so I've taken the actual Ultraleap hardware and integrated with a demo we did running just off our laptop. And so here I took a UI that wasn't built for a touchless interface and just applied it, and just to show you where we are to start off with, and then we could talk about what going forward would look like. So here you can see the UI, and it's a theater kiosk, and the very start is a scrolling list of movies and everything. It's like from nice big selection boxes, very easy to interact with. Right out of the box, there's a pointer that comes from the overlay on the screen that gives me an idea where I am, shows me where I'm pressing, so I get some feedback. And until we start getting to some of these smaller controls, there really is no problem interfacing with it. And even there, it's manageable. But we can discuss this in a moment. What would we do different if we were building this right up from the ground for a touchless interface? So it was a pretty easy demo to put together, and it just shows you how fast and quickly you can start prototyping and working through these ideas and seeing how a touchless interface would work for you. So if I move to the next thing, so the first thing to talk about is if you're bringing in these new technologies, whether it be voice, gesture, anything like that, you have to start figuring how does it come into my system. So most UIs are built already to have inputs coming in, whether it be a touchscreen interface, mouse, keyboard, and sometimes there's other interfaces. We have built-in gestures, other pieces like that. So the first way you can integrate a new technology is try and overlay it on top of an existing technology. So that's exactly what you saw in that demo, was we were actually able to have the input from the Windows system just actually give us the gesture controllers as if it was a mouse that we were interacting with, which gave a very easy, quick way for us to integrate with. So that makes it very nice and easy. But some of these different controls don't always map up one-to-one. Now, I'll speak a little bit here specifically about Storyboard, but if you're using a different system, the same concepts probably exist somewhere. So Storyboard is a runtime engine, and the way you interface with our engine is through an event. So everything inside of the Storyboard system is an event, and it triggers an action. An action could be screen transitions, animations, whatever it might be that drives your UI, the behavior. So we have made it very clean and easy because the way to interact with our system is through events. And so if you have a custom event coming in through another system, so if we go right back to the Ultraleap example, they have the ability to recognize custom gestures. So let's say I wanted to do a thumbs up gesture. And if somebody shows a thumbs up to the screen, that it does something. Well, in that case, you would have a piece of hardware, another task in the system or process running that would be grabbing the information from the Ultraleap API. And when it recognized the thumbs up, it would send an event. And inside the Storyboard system, we have an easy way to define events inside of a graphical event builder. And the nicer thing is, if this doesn't exist yet and you need to start testing it, when you're simulating and trying out your stuff, we also have an event ejector, so you can start faking in those events coming in that, somebody's thumbs upping your UI. As we all dream, people are just only ever going to give us thumbs up. So it becomes very easy to integrate these APIs, and pretty much any system will have some event stream, but because the UI in Storyboard is built on this mechanism that everything is event driven, it does become very clean how we bring these different technologies in. And I'm talking about the gestures here, but voice would be the same thing. Other different feedback systems would be also where either you can build it into the Storyboard application at a higher level, but just to get going, you can just leverage our event API and just start hitting us with the events. And so you could have just a task simply controlling that and pushing the events into us. So it makes it very quick and easy. And as you saw there, leveraging the existing APIs, it was super easy to bring the Ultraleap hardware in so we could actually try out what our system may look like with this system. As you get into integrating this into your system, you're slowly going to realize maybe my UI wasn't made the best. And that's what you could see as I was every once in a while just struggling a little bit to access our stuff. If you are going to do a UI based on something like this, or voice too, you have to really think through the commands. Gesture makes it so the way you point, there's a little bit of a accuracy that needs to make sure you hit. So the larger the touch zone makes it easier to be more accurate. The other thing that is available to be done is actually it's a little of an old school approach, is to sort of go with a snap to sort of focus approach, where as you move through it jumps over, and this would be kind of like as you moved focus in an older style event. Focus isn't used as much on touchscreens because you really drive the focus as you touch something, but you don't usually tab through a UI anymore because there's only a touchscreen interface. But if you go back to that where you actually highlight something when it's sort of hovered upon or selected, and then you choose it and then you hit it to actually drive the action, that helps people get a lot more feedback. So yeah, and that's where I was talking about user feedback. User feedback's great. So no matter what you're doing, you need to make sure if you're using these touchless devices, micro interactions are a great way. Even when you're using a touchscreen, if you touch a button to trigger an animation, you see this on your phone every time. Every time you hit a button, there's a little pop of an animation. It's great to tell the user that, okay, yeah, you did hit this button. We saw you. But always just let them know what's going on. In the example you saw in the video, they gave me a mouse cursor there to see what was going on. If you did the snap to focus and everything started highlighting as you move through it, that just makes it so much easier and simpler to know what's happening. Voice is a very good example. You always want to know, is it really listening to me? Is it getting the commands? Is what's happening? So if you're doing a voice feedback, a voice interaction, you want something to show that it's actually interpreting the voice at that moment. So always think about, how does the user get feedback to know what's happening? And then if you have users who aren't trained users or stuff, you should really think about how to give hints, provide instructions, whether it's just like a toaster pop down saying, hey, to interact, say these keywords, or to, just start swiping, and, just think about building that in. You can always turn things like that off if you have a trained user base. Let's say you're using it in a work environment. After somebody's used it for a day, they should not need the overlay hints and everything anymore, but it's always good to have and being able to turn on and off. So the last thing I just want to talk about quickly is rapid prototyping, and this gets into testing too. You really want to test out your ideas quickly. You want to make sure you can get up and going fast. Storyboard has been built all around. This is actually kind of the backbone of what our company does. When we start off, people are always crazy impressed with how fast we move, because we can bring in a Photoshop file, start adding animations, behavior to it within minutes, and actually push it down to a live piece of hardware running an embedded operating system. But this is so much more important because, as you're changing the way you interact with this, new ideas of your UI and what's the best way, you're going to need a lot of user testing, a lot of internal testing, a lot of user groups testing out different concepts and ideas. And you need to be able to implement them fast, try them fast. Also make sure you verify on real hardware, not only on your desktop, because it's, to see something run really well on your desktop doesn't mean how it's going to run when you get on real hardware and how it looks and feels with the real screen and all the different hardware pieces you're going to do. But the biggest thing I could tell you is get ready to iterate. Companies who write tons of code to get to a spot where they can finally see their prototype running or see their product, what it's going to look like at end release, they usually have a very hard time iterating because they did so much work in a sort of very tedious way. So the idea of iteration becomes very daunting, so that it causes them to be very cautious and not try as many different ways, because it's so tedious and so time taxing to try new ideas. And when you're integrating new technologies, especially if there's multimodal technologies where you're going to be interacting with your UI or your device in multiple mechanisms, you really need to get the user testing behind it, get the validation, and start thinking about how you're actually going to automate test this and different pieces with all these different interactions coming in, and understanding that an interaction between one user could be a mixed interaction. They could come in with a gesture and then start touching the screen, and then send a voice command. So if you're opening up more options, you just have to be ready to deal with that, be able to do the testing and be able to validate it very quickly. And I can't say enough about the Ultraleap hardware that I showed off there. It was so easy for us to put it together and actually show off a demo and just to get an idea of how that looked and felt. It was super easy, and a lot of different hardware provides things like that. And even when it doesn't, like I was talking about with interjecting the events until the hardware is ready to do what it can, you can actually still fake up the entire process and just inject the events from the tool and see how it runs and feels in those scenarios. So those are my main points today that I just wanted to touch on. As you're starting to look at touchless hardware, get ready to sort of test out things, get going, and get to target quickly to start testing out these concepts, and get ready to iterate. Just understand that, these UIs, as you try new interactions and everything, you're going to have to do a lot of stuff, and you're going to have to iterate quickly. And, making sure you have a tool that can manage that is very important. So, I'll leave you with, if you wanted to try something like this out to build up a UI that's touchless, there is a free version of Storyboard online that you can just download for 30 days for free and start kicking the tires. And, if you want to reach out to me, feel free to, and we're happy to set aside some time to talk to you about how you could easily start prototyping out the UI for your next touchless interface. So you can just reach out to me at my email at jason@cranksoftware.com. Anyways, thanks, and I'll pass it back to you, Megan.
Great. Thank you so much to all of our presenters, Alex, Jason, and Tom. We appreciate this valuable information. We do have a few questions coming in, and we invite everyone to add any others that you have at this time, but we'll start with the first question for Tom. So Tom, do you see the perception of touchscreens changing once the pandemic is finished? Is this going to be a long-term behavior change?
Thanks, Megan. That's a great question. I think nobody really expected that 9 months later we'd still be sitting here in lockdowns. So I think the short answer is there's a degree of muscle memory being formed anytime. The vast majority of people leave their homes today. They're checking to make sure that they have their hand sanitizer in the pocket, or if they approach a touch screen, an entry, any access point, you think twice about touching it. So I think although the panic is over to a certain extent, there's a normalization of a new normal with heightened awareness and cautiousness about touching things, whether that's bricks and mortar or digital. The awareness of public is forming in terms of like forming muscle memory per se. And I think from the business's perspective, businesses are looking at touchless interfaces as a form of differentiation, survival in certain cases, of course, as well. So it is sticky. I think I said in my presentation that we potentially are at an inflection point. And I kind of stand by that. And I think we'll look back over time and realize that this period in 2020 has really tipped the balance away from physical touch interfaces to touchless and touch-free.
Very good. Thank you, Tom. And while I have your attention, if I can ask another one directed at you, where can I see this technology in action today?
Well, from Ultraleap's perspective, I think one of the most visual implementations has been the launch of our touch-free application, which we announced a couple of weeks ago. We have several pilots across a variety of different organizations. Obviously, retailers, kiosk makers, quick service menu providers. We've announced collaborations with brands such as Lego. They had a great showcase in London over the past couple of weeks. Skoda, Ocean Outdoor, they've all brought this technology to many shopping malls, particularly in the UK. Here in the US, through our work with the likes of Sen and Warner Brothers, we've seen a lot of implementation in movie theaters, and unfortunately they're shut down at the moment, but it's one of the best deployments where you'll see a haptic and a hand tracking interface in some of the digital billboards in all the movie theaters. Cortina, a good partner of our firm, has done a lot of great work with the Aquarium of the Pacific, where they've integrated both haptics and tracking. So many of the public spaces where you'll see our technology, unfortunately, are shut down at the moment, but once they're permitted to reopen, I think the fact that the touchless interfaces are there will be will provide some reassurances to the users and form some sort of a differentiation for those businesses.
Very good. Thank you, Tom. We have a question in for Alex from NXP. Is this scanner the USB plugin type available on your NXP website?
Oh, thanks for the question. So no, not at this time, but stay tuned. And meanwhile, if any of you are out there interested to discuss about this technology, the best thing to do is contact us directly because there's such a range of use cases and applications. So it'd be very important at first to identify the suitable platform for your case. And then after that, of course, we'll tie together with our partners and work it out. Thanks.
Thanks, Alex. And again, while we have your attention, there's another question in for you. Where can I get more information about the i.MX 8M Plus processor that you shared earlier?
Good. So it's not yet officially launched. It's been announced, but we will be launching that soon. And at the moment, the documents are available under NDA. So please contact your local distributor or your local NXP person, and we can set you up with the NDA. Happy to share those docs. And then after we do officially launch, it'll be all on nxp.com/IMX8 is where you find everything for that family. Thanks.
Sure, very good. Thank you, Alex. Jason at Crank, we have a couple questions for you as well. The first one is, what is needed in place for Storyboard to integrate these different touchless technologies into the design and development of HMIs?
Yeah, as I mentioned, there isn't much that has to be in place. If you're able to get the events from wherever they're coming from, they can be injected in, because what Storyboard is doing is controlling the display. So we're reacting to events that are coming in. So somewhere, yes, you'll need a driver and such for these hardware pieces, and then you just need someone to interpret and trigger the UI as to when to happen. Now, sometimes that happens inside the UI, like, we do that for all the standard display inputs, and as things become more standard, we integrate them directly into the product, so it's just out of the box behavior. But if it's a new technology, usually somebody's going to use our external event mechanism that I mentioned in the talk, to send us an event, and then that'll trigger whatever you want to happen on the screen, whether an animation kicks off or it changes screens, or whatever behavior you're looking for there.
Very good, thank you. And another one for you. If Storyboard is not a code framework, how is the front end and back end linked or communicate with other processes and
Yeah,
processes?
so we are a runtime engine, so to speak. So, but we are all completely event driven. So it's the exact same, going back to the same answer. So you develop everything inside of our tool, which allows you a nice user-friendly way to put together your screens, build animations, all at a very graphical way. You're not working with syntax and stuff, and this makes it very easy for even your UI developers and designers to come in and actually edit timelines and deal with the assets and the fonts and the translations and everything like that. So they're not getting into syntax where they need to know how to code. And then the engineering team is able to stick on the other side of that API that I was speaking of and build up all the communication back and forth. And this really pushes our customers to a really nice, clean architecture that makes it very easy to upgrade and evolve the user interface without causing a lot of pain on the systems team.
Good. And I think we have one final question to be posed to Jason, it looks like. What would be the process for integrating multiple forms of touchless interactions into the UI?
Well, it sort of comes back. So right now, like, there's already multiple ways of input coming into the system. Inside our system, really what we're doing is we're tying events through. So so if you were talking about gestures coming in, you could have gestures coming in through the standard API where it just comes in almost like a mouse, and that's what you were seeing in that demo that I showed. So it was kind of moving around motion and presses, and they were faking up, and the nice overlay that Ultraleap built had a nice feedback mechanism. So as you started pointing, it sort of, the mouse pointer gave you some feedback to show you that you're actually selecting stuff. And so all those things, they came through our standard inputs. If you're adding voice in, it would probably be another piece that come in, but it would probably be coming either through a direct something on system. We've done examples with companies like Snips before and other voice recognition systems, but also other ones with like when it's over the cloud through an MQTT protocol, which would come to the UI through over the internet, and that would send us an event over a different API mechanism. So rather than the standard driver interfaces, it would be coming from an external event, and that would just drive the behavior the same way. Inside of Storyboard, really what you're doing is tying events to actions, and you can have one event drive multiple actions, or the same action driven by multiple events. So it's a many-to-many connection, which makes it very easy to bring in sort of a multimodal input mechanism and tie it all together.
Very good. Thank you so much, Jason. And with that, we're going to conclude today's webinar. We appreciate everyone's time. We encourage you to go visit the websites shown on the screen now, and certainly do reach out to NXP, Crank Software, and/or Ultraleap when your designs need us. We're eager to help in any way we can. Thank you for your time today, and have a good one. Bye-bye.